The title of this presentation is The Moon and the Milky Way and the Sun and the Seasons, and it is in honor of Robin Morris, a good friend that loved and valued both the earth and the heavens. In this picture you're seeing our galaxy, called the Milky Way. And the word galaxy comes from the Greek word galact, meaning milk. If you think of being lactose intolerant, you'll hear the similarity between those words. The milky light in the sky in this picture isn't water vapor, it's rather hundreds of thousands of millions of solar system with dust interpenetrating amongst the stars. So sometimes the sky is full of milky light like this, and at other times it looks quite different. A full moon absolutely dominates the night sky. It's 300 times brighter than all the other stars and planets combined because it's reflecting the sun's light back to us. This regular alternation of stars and moonlight every month is the first subject I will explore in the following. Let's take a look at how the moon appears in the sky night by night. This illustration shows period after sunset, and a thin crescent moon on the right side is just showing itself. This is the first night after a new moon when there's no moon visible. Every night hereafter, the moon is going to get a little bit larger and be visible after sunset a little farther to the left or to the east. So if we call this first night Monday, on Tuesday, you can see the moon at sunset is a little higher in the sky, and it's actually just a little bit wider as a crescent. And do realize that the moon is very much enlarged in the sky here. It's not this big in the sky, but I've made it so that it's easier to comprehend. By Wednesday, after sunset, the moon is higher, farther along to the east. And on Thursday, you can see it's getting a little bit bigger. It's waxing. That means it's growing in size. By Friday, it's getting closer to the south. And Saturday, Sunday, we have what's called a half moon or a quarter moon. And continuing on every night, the second Monday, the moon's beyond half. It's called a gibbous moon. Still waxing, still getting larger. Night after night at sunset, and the moon is more prominent. By the time you get to 2 weeks, the second Sunday, you've got a full moon rising as the sun is setting. When you put all this together, what you see is a sequence, day by day, where the moon is moving about 24 moon widths every night farther along to the east. As I mentioned, the moon in this illustration is very much enlarged. So when I say it's 24 moon widths farther each night, that's how much smaller the actual moon is in the sky, so that the positioning does fit that size. After a full moon rises at sunset, then every night the moon rises 50 minutes later. So the moon will be shrinking. It's actually a waning moon for another 2 weeks until it's a new moon. And that's your cycle of the month, which of course is based on the word moon. Now, one consequence of the moon's changing appearance is that it either casts less or more light in the sky. And as it does so, it interacts with the stars and the Milky Way that is visible. So when there's not much moon, if you're in a very dark situation, you can see lots of stars and maybe even the Milky Way. But as the moon gets brighter through the course of a month, the stars and Milky Way start to disappear. Let me show you how that works. Watch how the moon is, now it's dark and you can really see the Milky Way on the left. Now the moon is getting a crescent. It's a waxing moon. Look how the Milky Way has disappeared. And as we get to full moon, there are very much less stars. And then as the moon starts to wane, the Milky Way reappears. The upshot of this lunar change in appearance and its impact on the stars is that we get an alternation between a sky full of stars in the Milky Way and a full moon, and moving somewhere in between. But these are the two kind of edges of the spectrum when you have a clear night. And because there's milk in the sky sometimes, and the milk disappears and this round thing otherwise appears called the moon, Danish folklore explained the variation by saying that when the milk in the sky is visible, there is no moon. When the milk disappears, the moon, like a circle of cheese, appears. It's the congealed milk. And as that cheese or that moon shrinks, more milk is released into the sky. So that alternation between Milky Way and moon is something that is very common to our experience, common to our ancestors' experience, and that's where that idea of the moon is made of cheese actually came from. So in that folklore, there is some real wisdom about the appearance of this celestial feature. The next section of this presentation is devoted to the sun and the seasons. We're going to move from silver moonlight to golden sunlight. At our latitude of 44 degrees north here in Eugene, the flavors of spring, summer, fall, and winter are pronounced, and I want to examine what makes each so distinctive. But before we even get into the seasons, we need to talk about what causes the seasons. And it's not at all obvious, and I think that most people probably don't quite know. In fact, 25 graduating seniors at Harvard University were asked what causes the seasons, and out of 25, only 2 knew. Most of them thought, and I think that many people think, that the seasons are caused by the Earth's nearness or distance from the sun, so that summer happens when we're closest to the sun and winter happens when we're farthest from the sun. In fact, we're closest to the sun in January, which is winter in the northern hemisphere, so that is definitely not the answer. The explanation actually has to do with the Earth's 23.5-degree tilt. The Earth circles around the sun, and if you look at the illustration on the far left, you'll see that the Earth is tilted with the north, the top, tilted towards the sun. And that would be summer. That's where the north is leaning in towards the sun and getting more light and more heat. On the opposite side, on the right side, you see the Earth tilted with the northern part, the top, tilted away from the sun. That would be, and that is, winter. And the seasons are reversed. In the southern hemisphere, if you're in New Zealand, for example, in January, it's high summer and not our frigid winter. Also want to point something out. The closer you are to the pole, the greater the variation between summer and winter. So the farther north your latitude is, the farther away from the equator, the more you need a large wardrobe because winter and summer are going to be so different. If you live near the equator, it's pretty much the same all the year. I'd like to look at some representative places on planet Earth to talk about how the seasons impact our planet depending upon latitude. What we're looking at here, for example, is the city of Mumbai. It used to be called Bombay. It's a city of 20 million people at 20 degrees north latitude, about 1,400 miles north of the equator. Roughly the same latitude as Mexico City, Honolulu, Hong Kong, Hanoi, and Mecca. In Mumbai, there is not almost any seasonal variation. The difference between winter and summer is very slight. So things remain pretty much the same except for the rainy season. As we go farther north, you'll see that there's a much greater seasonal change. By the way, about 1/6 of the world's population, 1.3 billion people, lives at 20 degrees north latitude, in between 15 and 25 degrees north latitude. If we go 700 miles farther north to Cairo, which is what we're looking at here, 30 degrees north latitude, it also has 20 million residents, same latitude as New Orleans, Jerusalem, Shanghai, New Delhi. There's more seasonal change in Cairo because you're farther north. Summer and winter do have a difference. This is the most popular latitude on Earth to live at. A quarter of the world's population, about 2 billion people, lives at 30 degrees north latitude, between 25 and 35. And when I talk about not much seasonal change, Los Angeles is 34 degrees north latitude, so it'd be kind of like this. If you've ever been in LA in the winter and the summer, you know it's not a huge difference. You don't really need to have a super heavy coat that you wear in the winter. But as you move farther north, you certainly do need to have a bigger wardrobe. New York City, a great city, also with 20 million people, at 40 degrees north latitude. Same latitude as Beijing, Rome, Istanbul, Seoul. About a fifth of the world's population, or 1.5 billion people, lives at 40 degrees north in that zone. And Eugene at 44 degrees north latitude is very similar to this. Living here, you know there is a big difference between summer and winter. The length of days versus nights is pronounced. The climate, heat and cold, pronounced. By the way, the bulk of the world's population, over 60%, lives between the latitudes of 20 and 40 degrees north. So this is also a very popular latitude. Also, 90% of Earth's population lives north of the equator. So when we talk about the seasons in the north, that's what most of the people on the planet are experiencing. When we go 700 miles farther north, we get to London at 50 degrees north latitude. It's got 14 million residents, another big city. Same latitude as Paris, Vienna, Seattle, Vancouver. This is a more difficult latitude to live at because the seasons are so distinct. Only 1/10 of the world's population, or 800 million people, live at 50 degrees north. And as we move even farther north to 60 degrees north, with St. Petersburg, a city of 5 million people, even less popular because the seasonal change is so extreme. If you think of the seasons as being moods, when you live in St. Petersburg, the mood swing between highs in summer and the lows of winter, quite extreme. Oslo, Anchorage, Stockholm, Helsinki, all are at about 60 degrees north latitude. Only about 3% of the world's population, or 200 million people, live at these high latitudes of 60 degrees. And even less people live at 70 degrees north latitude. This is Tromsø, a beautiful small city of 70,000 people, great place to see the aurora, a fabulous place to go in summer because the sun never sets. But almost nobody lives at this latitude. A tiny fraction of 1% of the world's population lives at 70 degrees north latitude because this truly is bipolar in regards to mood swings. When it's summer, it's exceptionally light. When it's winter, it is profoundly dark. These 6 representative cities at 10-degree intervals from 20 to 70 degrees north latitude will be used in the following to help us visualize the impact of the seasons in the northern hemisphere. And again, Eugene is at 44 degrees north, so it's almost exactly halfway between the equator and the pole. Salem at 45 is exactly halfway. We happen to be in a sweet spot where we get the seasons, but we're not extreme. It's a really fantastic place to experience planet Earth. As you'll see, the closer to the pole that one is, the more exaggerated and more flavored the seasons are. So let's look at the spring equinox. Around the sun, you see the Earth, and it is tilted, but it's not tilted towards or away from the sun. The way it's situated, it's just parallel with the sun. And the result is that days and nights are equal in Mumbai, Cairo, New York City, all the way across to Tromsø. Everywhere on the planet on March 21st, the amount of darkness and daylight is exactly the same. And the way I'm portraying that is in these columns, the blue represents the length of night, and the yellow represents the amount of time the sun is in the sky, the amount of daytime. With the beginning of spring on March 21st, everything's equal. Let's go 1 month farther and watch how the Earth moves a little bit to the left. And look at how the columns have changed in 30 days. Mumbai, there's not much difference between the amount of darkness and the amount of light. Sunrise is at 6:15 in the morning in Mumbai on April 20th, sunset at 6:57. But Tromsø, at 70 degrees north, on April 20th, sunrise is at 4:18 a.m. and sunset is at 9:11 p.m. There's quite a big difference. As we move farther in spring, to May 20th, 2 months into the season, you'll see that again, Mumbai on the left, not much difference. Tromsø, it's daylight 24 hours. The sun never sets. In St. Petersburg, it's 60 degrees north. The sun rises at 5:11 in the morning and the sunset is at 10:42 at night. The days are really long. In Eugene on May 20th, sun rises at 5:42 a.m., sets at 8:38 p.m. Springtime, the 90 days of springtime, is characterized by the growth of light. Every day there's more daylight and correspondingly less darkness. And that is more pronounced the farther towards the pole that you go. Here's Eugene in the springtime, an absolutely beautiful time to be here when trees are greening up, new growth is showing itself, activities are abundant. The summer solstice is when the Earth is tilted, the northern part of the Earth is tilted towards the sun to its maximum extent. And that is on June 21st in the northern hemisphere. On that day, of course, Mumbai, not much change between sunset and sunrise. But in Tromsø, the sun never sets. In St. Petersburg, the sun rises at 4:35 in the morning and sets at 11:25 at night. So again, a tremendously long day. In Eugene, the sun rises at 5:29 and sets at 9 p.m. But every day in summer, the amount of light, every day as we move the 90 days of the season, there's a little less light and a little bit more darkness, even though lightness always predominates. So after 1 month of summer, and here's July 20th, you can see the columns haven't changed very much. That first month is still very, very sunny. But as we move into August 20th, the amount of darkness is growing in all of these latitudes. Eugene in the summertime, as we well know, is a wonderful place to be. Lots of light, the sun setting late in the day, rising early in the morning, and of course, maximum heat. By the time we get to the autumn equinox, where the Earth is now parallel again with the sun, it's not tilted towards or away from the sun because of its tilt. Days and nights are equal all across the globe. And every day of autumn, for 90 days, the darkness grows and the light correspondingly shrinks. And the farther north you are, the more this is accentuated. 30 days into autumn, you watch the Earth move a little bit farther, where the North is now tilting a little bit away from the Sun, and you see the blue column rise. Tromso becoming darker, Eugene becoming darker. By November 20th, the difference between daylight and darkness is quite extreme. Mumbai, no, not much at all. Even Cairo, New York, but Tromso, sunrise is at 9:58 a.m. and sunset is at 1 p.m. on November 20th. With the gathering darkness, many birds depart. They have learned how to deal with the gathering darkness by migrating and flying south in the autumn. Snowbirds do much the same thing. People go to Hawaii, people go to Arizona, people go to Florida to get out of the gloom of the dark autumn. Still a fantastic time to be in Eugene. We've got colors, mellow light, actually for many people I think the favorite part of the year. And finally you get to winter. The winter solstice, the northern part of the Earth is tilted as far away from the sun as it can be. As you might expect, Tromso, it's dark 24 hours a day. St. Petersburg, dark most of the day. The sun rises at 10:59 in the morning and sets at 4:53 p.m. Even though it's the darkest time of year in winter, it does have the marvelous feature that the light is returning. Every day in winter, there is a little bit more light than the day before, and the darkness is correspondingly shrinking. Always during the season, however, the darkness predominates. Christmas, December 25th, only a few days after the winter solstice, is a holiday where we remember that the light is returning. And so there is, around the Northern Hemisphere, a time of celebration because hope is in the air. A month into winter, the light is slowly coming back. And 2 months into the season, you can see that daylight is becoming more prominent. This isn't entirely representative of Eugene in the winter, but we do occasionally get snow. Winter is certainly the season where, if snow's going to happen, it will occur then. And after one full year, the Earth comes back to being parallel with the sun, not tilted one way or the other in regards to the sun, and equal days and equal nights return, and then the predominance of daylight occurs once again in the spring season. So that is the seasonal experience of planet Earth, and as mentioned, the farther you are towards the pole, the more you feel those seasons, the more flavor the seasons have. We've talked about the moon and Milky Way. We've talked about the sun and the seasons. I want to return to conclude this presentation with looking at the Milky Way a little bit more closely. This is our home galaxy, and if you get a really fantastic view of it, as in this picture from the Chilean Andes, you can see that our galaxy is a really prominent feature of the night sky. You've got the light of hundreds of thousands of millions of stars and dark dust. In our galaxy, we apparently reside about halfway between the core and the edge, and it's natural that we might wonder what we look like to those outside of our galaxy. How do we appear? We can't tell because we're inside our galaxy, but we can see other galaxies that bear a close resemblance to our own and suggest what we look like. For example, here's another galaxy that we're seeing through the stars of our galaxy. All the stars that you're seeing are in our Milky Way, and we're looking out through them at a great distance at another distant galaxy. a little bit like looking through the bars of a bird cage and seeing in the distance another whole bird cage. With this galaxy, we're seeing a very thin profile with a line of dust that goes across its equator, much like our own. If we look at another galaxy that's tilted a little bit but has the same form, we get further understanding of what we look like. Here's an exquisite galaxy called the Sombrero Galaxy. You can see that it looks a little bit like a flying saucer. It's got that shape like Saturn and its rings. You can see the prominent dust line, and that's where we would be. At least 100,000 million solar systems in this galaxy. The amount of life that is likely to be in the Sombrero Galaxy is really beyond imagining. I'm going to guess that there are many slideshows going on at this location. A galaxy that is similar to this but tilted a little bit more to our line of sight also looks like ours. This is called M81, and you can see the winding arms of the galaxy as it's rotating clockwise. The foreground stars, just like in the previous pictures, are close by, relatively speaking. They're in our own galaxy. This is much farther away. You might wonder, if this were our galaxy, where are we located? The red target mark shows approximately where our sun and solar system would be in relationship to the larger galaxy, about halfway between the center and the farthest edge. Another distant galaxy shows what we would look like from immediately above, looking straight down on us, if this were the Milky Way. It's a galaxy that is rotating counterclockwise in this instance, and our position amidst the stars and the dust, hundreds of thousands of millions of solar systems, would be approximately where the target mark is. Again, about halfway between the center and the edge of the galaxy. With this slide, we begin to see just how many galaxies there really are. Virtually everything you see here is a galaxy. There's an occasional star that's close by in our galaxy. It's got spikes around it. But otherwise, these blots of light are galaxies with immense populations of stars and, very likely, lots of life. To suggest just how many galaxies there are, however, we need to look at the Hubble Deep Field. This picture is the result of an experiment that was done in 1995, over 20 years ago, where the Hubble Space Telescope, far above Earth's atmosphere, turned its attention to an area of space in the constellation Ursa Major, the Great Bear, that appeared to be empty. Astronomers couldn't see anything there. It looked like it was just black. And so the telescope was aimed at that empty spot for 10 continuous days, unblinking. And after that amount of time, this was the picture that was revealed. In it, you can see about 4 stars that are nearby. Everything else is a galaxy. And the number of galaxies visible in this picture, of course, is thousands, and it suggests that the number of galaxies in the universe, somewhere in the order of at least 100 billion and maybe vastly more. Way more galaxies than there are human beings on planet Earth. And each galaxy is unimaginably huge, with an extraordinary number of solar systems. If we look at just a small section of this galaxy field, we can see it just goes on and on and on. Based upon the number of galaxies and stars that we can see, there are more solar systems in the universe, stars surrounded by planets with the possibility of life, than there are drops of rain that fall on Earth in a year. So the next time it's raining, check out a drop falling and think of that as an individual solar system. And when that drop hits a body of water and spreads into rings, it actually does look like planets around a star. It's enough to wash away any sense of self-preoccupation. The universe is fabulously large, spectacularly beautiful and amazing in the amount of potential it has for new developments. In talking about the universe, I think this picture represents some of the mystery and the wonder that we all participate in. This is an object visible in the southern hemisphere of planet Earth. It shows a star that is puffed off a very evocative form. It's a figure eight, suggestive of infinity, and in the very center, a beautifully fashioned eye. And quite appropriate, the glint in the eye is the star that puffed off this form. And so, obviously, there's lots that we don't know, lots that we want to explore, and we live in a wonderful environment to do so. In keeping with this perspective, I'd like to read you something from Michael Pollan's book, How to Change Your Mind. And it's an anecdote about Edgar Mitchell, who was one of the Apollo astronauts. And it reads as follows. Edgar Mitchell, returning from the moon on Apollo 14 in 1971, had what he described as a mystical experience. The biggest joy was on the way home, he recalled. In my cockpit window, passing into view every 2 minutes, the Earth, the moon, the sun, and the whole panorama of the heavens. That was a powerful, overwhelming experience. And suddenly, I realized that the molecules of my body and the molecules of my spacecraft, the molecules in the bodies of my partners, were prototyped, manufactured in some ancient generation of stars. I felt an overwhelming sense of oneness, of connectedness. It wasn't them and us. It was, that's me. That's all of it. It's one thing. And it was accompanied by an ecstasy, a sense of, oh my God, wow, yes, an insight, an epiphany. With that, I thank you for your attention, and I hope you enjoyed the program.